Okay. This is, I don't need these. That's all right. All right, let's continue from where we left off last time, which was looking at Lab 3. And so half of you have already, supposedly, theoretically, have already gone through these exercises. Do you have any questions at this point? Anything that you want me to talk about? Yeah.
For the list of random digits, when I was doing it, every time I did it, it gave me new numbers based on the time, but every number was the same. So it changed every time, but every number was the same number.
So it was the sequence of the numbers that were different?
No, like for instance, I'll click it one time, it'll say 1050 100 times, and then I'll go back and click it again, and it'll say 1090 100 times.
Oh, okay. So that's a logic error, in your code. So that would be you want to take a look at? Did you commit that?
Yeah.
Let's take a look at that. And what's your user account
It's
name?
just the first letter and last name, right?
No, no, the other one. The long one. Your first name underscore last name.
Oh, the Dylan underscore Higgins.
Dylan underscore.
Higgins.
Uh, so it would be this one here.
Yep.
So there's going to be an issue with your loop. And the loop is there. Now I want to comment about this. Let's go ahead and do this here. Let me start this up. I'm going to use Visual Studio. I want to suggest that you indent a little bit differently. Actually, this doesn't look like it will build.
I think you should.
Oh, no, no, here it is. There's the problem here. This line here is the body of the for loop. So that line right there is being repeated over and over again, 100 times. And I'm gonna critique your code, okay? And then we're gonna move it into a form that I recommend that you use, okay? So this gives me an opportunity to do that. That's great. Let me go ahead and create a new project here. So this will be a console, C++ console application. And let's call that, I'm going to call it Dylan. That was your name, right? Dylan? Remember that? Okay. I like to use an empty project, although you can see what happens when you use the non-empty project. It gives you more. It gives you some starter code that you can use, but it's specific to Windows, so it's not a portable starter code. That's why I don't like it. No, no, you use the procedure you've been using all along if you're upstairs. Unless you're in JB 360, there's another lab. Those machines in there are Windows machines. In there you can use Visual Studio.
So you can take, like the one you're working on this problem right now by opening that. So
It doesn't matter. You can do the same program in both environments. This is not a required software in the class. You have everything already available to you in the lab, and you don't have this unless you work across the hall in the other room. Okay. Let's add a new item called main. I like to call the file main because it has that main function. That's the entry point for the program. And one of the reasons, Dylan, why you didn't catch this error, logic error, it's a logic error because it builds, it runs. So it's not a compile time error, it's a runtime error. Or it's a logic error. It doesn't do what you want it to do. And one of the reasons that you didn't catch that is because you didn't use indentation. So here, I'm going to indent that line there to show that it is in fact inside the body of that for loop. And that's the purpose of indentation. You see, this part of the code is nicely indented here. These lines are indented. And that indentation helps to express the fact that those lines are inside the body of the main function. Now, the body of the main function has more than one statement. This for loop has a single statement in its body. If you can also have multiple statements in the body of a for loop. To do that, you need to use those braces in the same way that you use braces in the main method. This is an equivalent program. It's like adding parentheses that you don't need just to help improve clarity. And by the way, I always use braces when I write loops, whether they're for loops or other loops. And the reason I do that is because it helps to avoid this problem that we have right now. So you don't clearly see that there's a single line that's being inside the loop. Like, for instance, here's a typical problem that people might do this. You might see this. And they write it like that. And the indentation implies that all those lines are in the body of that for loop, whereas that's not the case. There's only one line in there. So to have all of those lines inside the body of the for loop, you need to use braces. And there are some teams, some programmers that require, as a coding convention in their projects, that loops always have braces, even when the bodies are comprised of single statements. So this is, in fact, this is where, let's see here. That's not right. This is what your code is doing. Let's go ahead and run that. Because I'm in Visual Studio, I'm just going to add this extra line right there, just to pause. There's a warning right there. So there it is. It's the same number over and over again, which is what we expect when we look at the code right now. So what you need to do is modify R. Something like this. Let's add 1 to R inside the loop. Now we shouldn't have the same number now, right? Because we're going to repeat the loop, and this time we're incrementing R. Let's try that. There it is, 657, I'm sorry, 6157, 6158, and so on. Okay, so now we're getting there. But what we want actually is to generate the random number r each time. So when we print r, we want a new r. So this down here, this statement is only done once in your program. This command here, or this statement, needs to be invoked 100 times. So you get 100 different random values. And so we want to move that into here. We don't need the plus plus. We don't need to increment r. It's okay to declare a variable inside this scope. This is called scope. So this is this r is visible only in this shaded area right here. We can't access r outside of here. I can't do this. This won't build. See the red underline there? R is undefined. Why is it saying I defined R there? Why is R undefined here? Because it's the scope in which R is defined is limited to the point where R was first defined to this ending brace. So if R, and I'm kind of getting off on a side tangent here, although it's essential that you know this. If we put the definition of R out here, you'll see that this is now acceptable. There's no longer an error message there. That's because R has been taken out of that kind of inner scope. It's been taken out of that multi-statement block. You can call it a multi-statement block. And we put it at a higher level. We gave it greater scope. Now, you can do this, but you can't do this. Because here, and you can see, the Visual Studio is showing that R is undefined at this point. So the visibility of R, or the existence of R, starts from where we declare it, which is here. Here we have a data type called int, followed by the variable name R. At that point, the compiler assumes that R exists or is visible. And so we cannot access R before that point. We cannot access it here. By the way, this is specific to C++ language, but it's also the case in many other languages. But in some languages, what I'm saying is not quite right. In JavaScript in particular, if you're writing in JavaScript, R is defined here. Because in JavaScript they do something called hoisting, whereas the definition of R is hoisted up to the function scope in which it occurs. So it's as if R was declared right after that opening brace. But that's JavaScript, that's another language. So just wanted to mention that some of the rules that we are memorizing in this class apply only to C++ and related languages like Java and C# and so on. So let's put the definition of R inside the for loop again. What some programmers do, and they consider this better style, and that is that they'll declare R outside the for loop and then use it inside that body. And in the old days, or in certain languages, this would be more efficient, actually. But in fact, because the compiler does optimizations, these two programs, two versions of the same program, really, I believe, generate the same machine code. But the problem with this approach here is that it gives, it increases the visibility of R to an area of the program that doesn't need to access R. So that increases the chances of having a logic error. So in fact, here's the logic error right there. There's no reason to print R there. So that doesn't serve any purpose, and yet the program builds. So by allowing R to have more scope, allowing R to be more visible to more areas of the code, has led to a mistake. That's why I don't like to follow this particular coding style. I like to limit the visibility of R to as small an area as needed. Now this line is invalid. We need to remove that, and it serves no purpose anyway. So let's see if how this works. And by the way, this line should not be indented. There's no reason to do that indentation there. So let's try it again. There it is. These numbers now look random. Well, of course, what's missing at this point is we need to embed these numbers inside of the list item HTML tags. So let's go ahead and do that. Yeah.
Lastly, you mentioned that we're going to need C time, and on top of there's another one. Do we also need it on top of that program?
Oh, is C time? Yeah. Yeah, we need this. We need this in order to call srand here. Oh, I'm sorry. In order to call time. I'm sorry.
What about the next one? What would be?
The next line, CSTD lib, C standard lib. This may be required for srand. Let me try it. No, it's not needed. Thank you for that question and that observation. That's very helpful. This include line is not needed. So what we need to do is enclose the random numbers in the li tags. So we output a tag, we output the number, and then we output what's called the closing tag. And that's what the closing tag looks like. It's got a slash in there. So they're like bookends. It's start, put the data in there, the text, and then we have an end. It's called markup. So you're annotating text. This is the beginning of the item. This is the end of the item. Everything in between is the item. So that word markup, that comes from typesetting. So in typesetting, you've got, in the old days, you put together the block of type, this metal type, print a sample sheet, give it to the editor, and the editor would then annotate it with a markup. And that's where the word markup comes from. So this is HTML markup. HTML is a markup language, or a document annotation language. All right, let's, so we try this. Oops, we didn't do it right. What happened? Oh, actually, it is right. It just doesn't read well. And we may have an extra, see, this is the opening tag, the number, the closing tag, opening tag number. This is okay, actually. This is a valid HTML document, and this will render correctly in the browser. But it's hard for a person to read. So let's go ahead and fix that. Let's get rid of the, we don't need this here. In fact, we should put it here. That's where we need the new line, right there. Okay, that looks better. It's easier for a human to read. Once again, for the purpose of the machine, both forms are acceptable and will produce the same result. Okay, and just to finish it off, let's go ahead and look at the what that web page would look like. And to do that, I'll do it this way. So there's two ways of doing that. I'm going to modify the configuration. Call it so I'm going to use this. Oops, it's not double. Actually, this double symbol here is valid, but it concatenates onto an existing file. Whereas if you use a single greater than symbol, it overwrites a potentially existing file or creates a new one. Let's take a look at that. Let's run it. See, it's not displaying anymore because we've redirected standard output to a file, and we've detached it from the console. So it's no longer, the output that we're writing is no longer getting channeled to the console. It's now getting channeled into the file. On the other hand, we still have that cin statement here. And we didn't modify the standard input stream. So the standard input stream is still the keyboard. So it's waiting now for me to hit enter. Or any key, actually. I think C and get will return for any keystroke. Or any character entry. I think if I hit the shift key, it's not going to return. So just to be precise, I press shift, I don't get a return. But if I press A, oh, that doesn't return either. I guess I do have to press enter. Okay. All right. So let's take a look at the, I think it was in there. There it is, test.html. There's our file. Seems to work okay. Any other questions about this particular problem or any of the concepts that we're talking about? We can move on to one of the other problems. Maybe the second problem. I heard that, I talked to Manuel, the lab assistant, said that some people are having trouble with the second lab exercise. Do you want to look at that? Okay. Let me just to have a variety of presentations here. Let's log into the lab and work on the lab machine. And so we need to go through JBH 3-1. And we can't work on that machine. We have to log into another machine in the lab. So JBH or JB359 dash a random machine. And I'm going to go into temp. Yeah, we already have a file set up for us, so let's use that. Let's call it main.cpp. Let's remove the a dot out just so we make sure we don't get confused. And let's edit the file. And let's see, what is that exercise? Whoop, not reading 3. Lab 3. Write a console program that converts meters into feet and inches. The program starts by asking the user for a measurement in meters. The program should accept a floating point number. After getting the number, the program computes the number of feet and inches equal to the specified number of meters. The program outputs feet and inches as whole numbers. The program should round the number of inches correctly. Test that your program produces the following outputs for the given input. So we need to specifically test these values. Okay. Let's go ahead and do that. So let's prompt the user. Enter a value in meters. And then, and look at this. This input here is a floating point number. So we're going to need a double. And we'll call it meters. So we're going to prompt enter a value in meters, then we're going to input the meters, and then we're going to convert it into feet and inches. But I'm not going to do that yet, because I do things incrementally. I'm just going to test this part of the solution. Oops, that's not right. And I can see there's, yeah, that's all right, I guess. Enter a value in meters. 0.3048. Your number is 0. So, we did probably we need a. It would help if we had a new line in there. Let's put that in there. I'm using the up arrow to re-execute commands. Yeah, it looks better. There's two tricks to help you speed up your work on Linux. One is to use history keys, which is up and down arrow, and the other one is to use the tab key, which is command completion. All right, so once we have the number, let's figure out how many feet are in that value. So let's calculate it here. We'll do something like this. We have another value. I'm not going to make it a double because we want the number of feet to be a whole number. So let's declare it as an int. And let's set it to something. 3. And then just practice. Let's get there. So we're going to output this. We're going to output the feet. And then we're going to output a space and then the characters ft. And just to pretend, you know, that we have a solution when we don't, and that's called stubbing, by the way. We're going to stub out a partial solution here. We're going to make it look like we have a solution when we don't have one yet. So let's go ahead and we have feet and then we have inches. And we'll put in here. So that means we also need inches. There are two integers, one for the feet, one for the inches. And then let's suppose, you know, this will be some kind of calculation, right? It's times 2 divided by 1.1, whatever the calculation is. And we don't know what that is yet, but we'll figure it out later. So we get two values, feet and inches, and we get it from our meters that got inputted in there. And yeah, just to show that, let's go ahead and put that in there. So we're going to use meters somehow. We're going to use meters in there in some way, just to show that. Just do that. And let's go ahead and see if this it gives us a nice output. Just see if the user interface works. We know the formulas are wrong. Enter a value in meters. I'm going to do 2. But not quite there. We need a space after the T. But that's basically pretty close. We need a space after this T. All right. I'm not going to run that. That's too simple. All right. How are we going to figure out the number of feet? Well, let's see. How do we convert meters to feet? Let's declare. Let's do it like. Let's figure this out. Did the book talk about const yet? Const. Double. Did the book talk about this yet? No. Okay. So let's do that here. We're going to have, there's going to be some conversion value. How many, what do we need? Do we need how many meters in a foot? Or do we need to know how many, well, how many inches in a meter? How about that? Inches per meter. Anybody know how many inches are in a meter? Let's suppose it's 36, and we'll look it up later, okay? 39.7. 37? 39.37. You should memorize this in case you ever travel out of the country, right? You do this calculation. Inches per meter. There we go. So if that's that many inches, so let's do it like this. I'm just gonna just think out loud here. I'm going to declare another value, which is total inches. And it's the meters that we have times the inches per meter. That'll give us, there's a conversion from meters to inches. But that's a double, right? And we don't want to output a double. We want to output an int. But let's start with a double. I mean, I call it total inches. We can call it inches. I think that's good enough. Total inches. So if we had total inches, well, I'm going to show you how to do this. Yeah, I can see how this is a tough problem, actually. There's no looping in here, but it has to do with the difference between a floating point value and an integer value, and how truncation and rounding is done. So if we have the total number of inches, lost connection, there we go. We have total inches, and we divide by 12. That should give us the number of feet, right? Let's see. Let's suppose we have 13 inches. So if we take 13, that's a foot and an inch. So we take 13 and divide by 12, that's going to give us 1 point something, right? 1 point something. So we want to put 1 point something in an integer variable called feet. But 1 point something isn't going to fit in there. It's not the right data type. An int can only hold a whole number. It can't hold a decimal. So what happens is the compiler accepts this, but it generates machine instructions to truncate the number so that the decimal part of the number is simply discarded. It's not rounding. It doesn't round up or down or anything. It truncates. So if we have total inches were if the total inches were 11 or 11.999, if that were the total inches, feet would end up being what? 0. Right? So what you said, 0? Yeah. Because it's truncating. It's a value that's less than 1. So it doesn't round it up. So this should give us the right number of feet. Let's see if that works. Oh, actually, we have to do this inches per meter. So 1 meter. So 1 meter is going to give us a little more than 3 feet, right? Right, because it's 36 inches for 3 feet and 39 inches for 1 meter. So I enter in a 1, the number of feet is going to be 3. Is that right? Okay, let's test that. And remember, inches isn't going to be correct, so we can ignore that. One meter. 3 feet. Okay, we got that. We got that part right. All right, so we know that we have 3 feet. Well, we know that the feet were probably, we haven't tested all the different possibilities, but you know, at this point I'm confident that we have the feet done correctly. Now we have to figure out how many inches are there. So we have total inches. And what we're going to do is we're going to take out the feet that we've pulled out of it. And it'll be like this. So our total inches, let's think about it here. We enter in a 1 for a number of meters. Then we come up here and we store in total inches the value 39.37, right? Because that's 39.37 times 1. We entered in 1 for meters. So total inches has 39.37 in it. And then we divide that by 12. That gives us 3 with that truncation operation. So feet now has 3. Total inches is still 39.37. So we want to take out the 36 inches for the 3 feet that we're already, using. So that means we had 3 feet. We're going to multiply by 12 to figure out how many inches it is that we're using up with our feet number. So that'll be 36. This gives us 36. So we have our total inches, which is 39.37, and we subtract 36. So we're going to have 3.37. So it should be 3.37. So inches should be 3.37. Does that make sense? Let's see. That's our hypothesis. Now let's test our hypothesis. Oh, it's an integer, 3.37. So it truncated. So we just got 3. The 0.37 has been dropped. So it looks okay. Let's do, but what I'm concerned about is the rounding part now. The program should round the number of inches correctly. Oh, so maybe if we type in a 2 here, we don't get the right value. Actually, let's go ahead and do that. So 2. So if we do that on a hand calculator, we should, if we round up correctly, I think 2. You need to do rounding to get 7 inches. So 2 meters. See, now actually the number of inches is not being, it's greater than, the decimal component is greater than 0.5, but we're not rounding, we're truncating. So that's why I created this test case just to spot the problem where we're not doing rounding. Because this test case where we type in 1 meter, that doesn't trigger this logic error where we've omitted the rounding operation. But this test case where we type in a 2, that reveals the logic error or the absence of rounding in the program, which is a requirement of the problem. So how do we do rounding? Well, rounding is there's a standard trick there. You just add 0.5. And so you add 0.5 and then you truncate. So think about that. If the decimal is 0.5 and you add 0.5, you're going to go to the next whole number. That's rounding up. If the decimal value is 0.49 and you add 0.5, you're going to get 0.99. You truncate and you discard the 0.99, so you're not rounding up. So that works. 0.49 works. Question? Say it again. Did I do something wrong here? Oh, M. Oh, that's just a mistake. M stands for mistake. Thank you. Thank you very much. Okay. Let's remember, we don't want to just run it now. Don't forget, you got to build it. All right. Enter a value in meters. 2 looks good. All right, let's do the last test case. 0.3048. Oh, something's wrong. What happened? Oh, you know what it is? It's the number. What is the... Can we get a more precise number for this? All right, let's look it up. One meter is that many inches. And I'm just blindly believing that. Zero point 3048. Still doesn't work. I think my test case might be wrong. So this is, what if we did 0.30, 0.30, and let's make it, I'm getting 0, right? So I want to make it a little bit bigger, 49. How about that? Oh, that one worked. My test case, I don't know, maybe I was, because the number is so small and we're dealing with a hair there. You have a question?
The meters were what was that 3.3048. If you divide that, or you times it by 3.208, which is the amount of feet like
Yeah.
per meter, it's not one. It's 0.9999 feet.
Yes, too small. The test case is not good.
I got mine to work in the lab yesterday.
See, that's the thing, you know,
Maybe you did.
in the computer, the representation of numbers is approximate. So, for instance, 1/3. You cannot exactly represent 1/3. So let's use, I'm going to use 9 there. Does that work? Can you do that test with this value? Just instead of an 8, make it a 9. So when, we're just shaving a hair off here, right? It's, internally, these values, there's a lot of rounding, or not rounding, there's a loss of precision. Because in a double, you've got eight bytes. You can't represent 1/3 as a floating point number with any finite number of bytes. So 1/3 is going to end up being something other than exactly 1/3. That's just as an example. So I think that we're just hitting the boundary precision. What do you get for that?
It was.
This is okay?
Yeah.
This gives us 1, right? So we fixed the test code. The test code was broken. Or the test cases were not good. Okay. Are there any other questions or issues you want to? That's it? Okay. I think that's all we need to cover today then.